Hi, my name is Dulce Rocio Torres Juarez. Today I'm going to explain a technical topic that is who calculate the stability of a slope. Okay, we solve this example. The example say on a slope of an organization whose crown sits a building that alone in 180 kPa. It has identified a block of limestone rock that is susceptible to creep rupture, geometry and mechanical parameters of discontinuity, and the rock form shown in the following figure. We can say that we have the amount and that the distance of this slope. Okay, and we can solve the first step that we will use the trigonometric functions to know the distance of L, B, T, and B. Uh, we need to divide into triangles. In the first, we need to calculate this distance L and B, and we solve the next form. We need to divide 12 between the tangent of 80 degrees, and we have 2.11 meters. And for to calculate L, we need to divide 12 meters between the sine of 80 degrees, and we have 12.18 meters. Well, we know this distance that we use the continue, and for to calculate the distance of the we need to do the next operation. We will for B we will divide 88 meters between the tangent of 55 degrees, and we have 5.6 meters. For next, we need to calculate D, and we will divide 8 meters between the sine of 55 degrees, and we have 9.76 meters. Okay, that we know this distance. It's necessary to the section on the slope in the we have 4 figures. 1, 2, 3, and 4. Well, that draws now the total area of the slope. We need to know that each of the areas. For the one, we need to multiply B 2.11 meters by 12, and this and the next we need to divide, obviously, between two, and we have 12.66 meters for ar- the area 2. We need to, it's the same because it's a area of a triangle. B, B by base by 8 between 2, in this case 5.6, sorry, meters by 8 between 2, and we have 22.4 meters for the area 3. We need it's only square, and we need to calculate or multiply 3.49 meters by 12 meters, and we have to result 41.88 meters, and the area 4, sorry, is 4. We need to plus the the area number 1 plus area number 3 um, less area number 2. That is 12.66 plus 41.88 less 22.4, and we have 32.14 square meters. Okay. Um. Okay. Mm, so sorry. We will to calculate the components of the current loans and forces, but we need now the weight of W4, that is, and we need to know the weight of Q, that is a specific weight, that uniform weight. I'm sorry, I don't remember well, but we need to multiply that the area for the weight for we need to multiply the area for to that another long, that is this of deep 30, 32.4 square meters or by, sorry, 24 kilonewtons between a cubic meter, and we have to result 771.36, sorry, kilonewtons between meters. And for to calculate 8 cube, sorry, we need to multiply the loan, this loan that the building by 3.49 meters. That is this distance. We know this distance that if we less, sorry, yes, uh, 5.6 meters less 2.11 meters, and we know this distance. And we have the result, 628.2 meters by meters. Sorry, I forgot that. Write this. And for the next, we will calculate the components of the current of the forces with two dates. And we need to calculate first this um, this date. Okay, RA, and we need to multiply C40, and if you ask you what D is, this or this, uh, we can we can see that we use this, and this letter C, that is this. It's another parameter, and that is 80 kPa. We have that 8 kPa by 9.76 meters, and we have result in 780.80 kilonewtons. And for the components, we need this result. We need to this gain for the design of the this angle for to the components. We use the same angle, that is the 55 degrees. Okay, for the w for x, we multiply 70 point 36 by the sine of 55 degrees, and we have 631.88 kilonewtons. And for the, I'm so sorry, there is J, and it is the same case. For for the wind for J, we need to multiply 70 100 70 71 700, sorry, 71.36 kilonewtons between meters by uh, by the cosine of 55 degrees, and we have 442.43 kilonewtons. And for to the components of y into cube, we need to for x, we need to multiply the y of cube, 688.20 kilonewtons between meter, and by the sine of 55 degrees, and we have 544, sorry, 514.59 kilonewtons. And for day, we need to multiply 628.20 but by the cosine of 55 degrees, and we have to result 360.32 kilonewtons. Okay, now for this problem, we need to know what is the safety factor when we have a dirty situation and when we have a one situation. For the first case, we need to calculate these parameters, and if FD and FS, that is safety factor. First, we need to know M, and we need to the 400 442.43 plus 360.32, and we have 802.75, and this date, that is that the component of G of the W4, and it's the same case for 2WQ date, and for the FE we need to the date of RA, that is 780.80, plus that the value of n by the tangent of the 30 degrees, or for this reason. Why 30 degrees? For this reason, for this is the reason that we use 30, and we have 1244.26 and of the of FD. We need to multiply the component of x plus the component of x that W4 and WQ respectively. Then we have 100 146.45 the all results we have in Kelvin, and for the search factor we need to divide uh, this value between this value, and we have 1.08, and then well, we know this result. We can say that the slope is stable in a dirty situation, but if we have one situation, we need to do the same process, but of the dirty situation, we use the no, sorry, yes, is the obviously we need to use the the components of W4 and WQ for X for to calculate N. Sorry, is a component J. Yes, and we can save another date. This date that is uh, oh no, I'm sorry, I don't what is process, but we need to that another date that is uh, the letter the letter E, that is 1/2 um, by a specific weight by the height, the square height, sorry, with with these dates. We know that is um, 1/2 by 90.81 because it's the specific weight of the water uh, by 4. Yes, there is a 4. For this, we calculate that is part uh, square that the height, and we have to result in 78.44, and for the EX, because we need to calculate it the same situation of the the components of X and Y, and for the E is of value on it, that is 78.44 by the cosine of the same angle 55 degrees, and we have to result 45.01, and for the EJ, the component J, we need to it's the same, but with the sign, that is 78.48 by the sign 55 degrees, and we have to result 64 point 28 this reason for this state. Okay, to end, uh, we need to use the component w4j plus the component of wqj less this, and we have the result in 7,138 um, 15 kilonewtons, and for the it's the same situation that the situation for to calculate fa. uh, the result of ra plus the result of n by the tangent of 30 degrees, and we have to resolve 100 to 1206.97 kilonewtons, and for FD we need to use um, the components of X for W4 and WQ respective. Um, this is the yes the component X of W plus the component X of WQ plus the component of the of E, there is 45.01, and we have the result 101,091.7 kilonewtons, and for to calculate the safety factor, going to divide 100 1,206 point 97 between 1,091.46 kilonewtons in the same case, and we have to result 1.01, and we can say that is stable, and that is the all for today. Thank you for your attention. I'm so sorry for the inconvenience. We see in the Bye.